For this introduction, we're going to talk about factoring by grouping. So what we need to do is first of all recognize what sorts of polynomials let us know that we should probably factor by grouping. As it turns out, I've got x cubed plus 4x squared minus x minus 4 here. It has 1, 2, 3, 4 terms. That's the key part that indicates factoring by grouping is going to be possibly useful. Okay, so what we're going to do is just group the first two terms together with parentheses. We'll group the last two terms together with parentheses, and if we have nothing in between, then it's going to be a multiplication problem. Unfortunately, that's not what we want quite yet. We're not going to be factored quite yet, so we're going to put a plus sign in between. So again, the first two terms in this first group is going to be x cubed plus 4x squared. In our last group, we're going to have a minus x minus 4. Okay? You always keep the signs of the last two terms exactly as you see them. Always keep the signs of the first two terms exactly as you see them as well. And when you go ahead and take a look at these groups now, we can just focus in primarily on this first group right away. And we see that, oh, there's something in common. Mr. Potier, what do we see in common?
X squared.
We see an x squared in common. And when we factor out an x squared, which is division by x squared, we're going to be left with an x and a plus 4 is what I'm left with when I divide x cubed by x squared. I'll be left with x. When I divide 4x squared by x squared, I get 4. On the other hand, though, Ms. Jones, what are we left with when we factor out what's in common over here? Or rather, in particular, what are we going to factor out?
Minus 1.
A minus 1. And so when we factor out a minus 1, we'll have plus a negative 1, which is the same thing as minus 1 itself. Okay? And when I factor out the minus 1 that was in common in both of these terms, I will be left with just x when I divide by a negative 1. And I'll be left with a plus 4 when I divide this term by what I am factoring out. And so all of a sudden, now I have x plus 4 showing up in both places. So I can go ahead and factor out the x plus 4. I can bring it out towards the front, or I can bring it out towards the back, which is because of the commutative property of multiplication. But I'll just, since I see it in the back, I'll just pull it out to the back, x plus 4, since it is now the common term, or the common factor, rather, of the first and the second terms here. Okay, so when I factor out the x squared, or excuse me, the x plus 4 from the x squared times x plus 4, I will be left with, first of all, just x squared. But when I factor the x plus 4 from this minus 1 times x plus 4, I'll be left with a minus 1. And so we are almost done. Most of the time, most students would stop here, but don't be one of those students because we haven't completely factored this. If you go to one of our other videos, you can see that x squared minus 1 is called a difference of squares because x squared is a perfect square and 1 is also a perfect square. So it factors as x minus 1. The two things that are getting squared show up here and here, x and 1. And you use a minus sign, and also x and 1 show up again, but now use a plus sign in between. Okay? So that's how the x squared minus 1 factors, and to complete this, don't forget the x plus 4 that trails at the end. And so there is our final factorization. X minus 1, x plus 1, and x plus 4. And this time we're going to do factoring by grouping again. And so when we factor, group the first two terms together, we're going to get a 4x minus 9y. Grouping the last two terms together, again, remembering to include their signs, we have a minus xy and a plus 2. And always, 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 as we're factoring by grouping, our first step is just to put a plus sign in between. Okay, so we still see exactly the same equation, except with an extra plus sign and with the extra 4 parentheses overall. And again, we try and factor out what's in common in the first two terms. 4x and a minus 9y. The numbers, the only number that's in common is going to be a 1. The x's and the y's, neither of those are in common. So the only thing we could factor out is just a 1. But factoring out a 1 won't change it. So I just leave it alone. On the other hand, on this portion of the factorization problem, I see a minus 18xy and a plus 2. Both of those are evenly divisible by 2. So I can pull out either a plus 2 or, if I really wanted to, a minus 2. So let's just try a plus 2 for right now. When I factor out a plus 2, I'll be left with negative 9xy. And when I factor out the plus 2 from plus 2, I'll be left with 1. Because remember, you're doing a division. 2 divided by 2 gives you 1 as your answer. Unfortunately, though, now, when I look at the two terms, I have a binomial of 4x minus 9y and a binomial of negative 9xy plus 1. These two binomials are not in common, so unfortunately, this factorization is not going to work. However, all is not lost. What we can do is actually just reorder the terms. And if we go ahead and reorder just these second two terms, we're going to flip them around, and we are going to keep their signs with each other. So in this case, they're both negative. But if one was positive, one was negative, you would need to make sure that you keep the sign with it. So when I reorder these terms, I have 4x minus 18xy minus 9y plus 2. And now I try and factor by grouping. So again, put the first two terms in parentheses. And again, put the last two terms and their signs in parentheses. And again, put a plus sign in between. This time, when I see what's in common in my first set of terms, I actually have a 2x in common. What's left over when I divide out by 2x? I'll just be left with a 2 and a minus 9y. Be very careful about it. Negative 18 divided by 2 gives us the minus 9. X divided by itself is times an extra 1. And y divided by an extra 1 is just going to be y. So negative 9y when you multiply it all together. And over here, on the other hand, there is nothing actually in common other than just 1 itself. And again, I always have the option of pulling out a positive or a negative factor. So if I tried to pull out a negative factor, though, unfortunately it's going to flip the signs. And if you actually look carefully, you can already see that this binomial has a positive 2 and a negative 9y, just like this binomial has a positive 2 and a negative 9y. It's just in the other order. So I can, like I did before, reorder these terms and have 2 minus 9y. The only thing that I implicitly factored out was 1 that was in common. And now when I factor out the 2 minus 9y that's in the first term and is in common with the 2 minus 9y in the second term, pull it out towards the back, or you can pull it out towards the front. But when I do that, I will be left with 2x is all that's left in my first term, this big long term. And the only thing that's left in my second term is a plus 1. And there is my factorization. Hope you've enjoyed it.